Action.
Oh hey, didn't see you there. I'm Raph. I'm an expert scientist. Do you want to learn about Newton's 3 laws of motion? Of course you do. Well, I'm going to teach you them all, starting with the first one. So, as I was saying before, I'm going to teach you the first rule of Newton's laws of motion. Let me just consult my handy science book. So, as the first law mentions, an object at rest stays at rest, and an object in motion maintains the same speed and direction unless acted upon by another force. In which ways could this relate to us? Oh yes, when you're playing soccer, this motion implies a lot to it. As in, if you were to kick a pass, have you noticed how the ball would keep going unless other forces, such as friction or gravity, stop it? Here's a clip that'll show how. Not only does that action apply with stopping the ball, it also starts with starting the ball, the same thing in soccer. Let's say a ball is just standing there in the same place. It's fully stationary, nothing is moving it. Have you ever noticed how it's not going to move by itself? No ghost is going to come and kick it. You have to kick it yourself. That also shows the law. It's going to stay in place until another force is acted upon it, just like this. You know, this Newton man was actually very intelligent. So as you know, he has 3 laws, and this happens to be the second one. The relationship between an object's mass, m, its acceleration, a, and the applied force, F, is F equals ma. Acceleration and force are vectors. In this law, the direction of the force vector is the same as the direction of the acceleration vector. Well, you know, this one actually is the most important because it allows us to calculate certain dynamics and whatnot. Well, but you know, it's actually not that hard once you think about it. Let's say you take something that can move around easily. Oh yes, like a skateboard. And so, this is a fixed mass, and it takes a certain amount of force to move it right or left. So, you see, let's say I'm pushing it, I don't know, at 5 newtons. That's not a real measurement, but let's pretend I am. So it takes 5 newtons to pull it at this speed. And so, since this is a fixed mass, and its certain weight is like 120 pounds, it's not actually that much, that's a large dramatization, then when you add extra mass, that means that you're going to have to add extra force in order to move it at the same speed. So, since we were just pushing at 10 newtons, we're going to have to push it, let's say, at 15 newtons. That's really all there is to it. And from that law, it brings us to our final and third law. Let me just consult my handbook one more time to find out what it is. For every action, there is an equal and opposite reaction. Well, what does that mean? Alright, think of it this way. When you push on something, like let's say I push on the ground with my feet. Did you notice how I went slightly upwards? So what it practically means is when I push down, like say I push down with 20 newtons, the ground is practically pushing back up with another 20 newtons. What's a good example of this? Oh yes, when you go on a trampoline, have you noticed how the harder you push down, the more you're going to go up? That's an exact example of the Newton's third law. Another example would also be when people are skateboarding, and it's almost the same thing with the trampoline. Whenever your feet, they push down on the skateboard, you're able to jump upwards and do some sort of trick. There's another example. And this has been Newton's 3 laws of motion. I hope you enjoyed, and I hope you actually learned something from this video. Thank you!